So this is a video on a handful of questions from the practice final. On this question, we have an expression. They want us to factor it, and you might get a little confused because there's both x's and y's involved, and there's four terms. You should always try to pull out a GCF, but you can't pull out, like you can pull out an x from here, from there, but you can't pull out an x from here. You could pull out a y from here, from there, but not from here or there. So there's no GCF, there's no common factor. So what we're going to do, since there's four terms, is we're going to try to factor by grouping. So step one would be to split it into two groups, x squared plus xy space plus 6x plus 6y. And then step two is to actually factor something out of your first group and then factor something out of your second group. Even if you can't factor out anything, factor out a 1 just for the sake of doing step 2. So we're going to factor something out of the first group. And in this binomial, there's x's in both terms. So I could pull out at least 1x. So that's what I'm going to do. I'm going to pull out 1x. And what would I have left over on the inside? I would have an x plus y left over on the inside. If you look at the second group, you could pull out a 6, the multiple of 6 from both terms. So if you pull out that 6, you are going to have an x plus y left over on the inside. Okay, so that was step 2. Step 3 is to take a step back and pull out the common binomial in both groups. So your first group has the binomial x plus y. The second group has a binomial x plus y. We're going to take this common binomial and pull it out to the front. So I'm going to write it over here, out in the front, the x plus y. And I'm going to put some exaggerated parentheses so you could clearly see that the x comes down and the positive 6 also comes down. And there's a blank spot here because I pulled out the x plus y, and a blank spot here because I pulled out the x plus y. So this is your factored form with correct size parentheses, x plus y times x plus 6. So they asked us to factor. We have factored it, right? If we take a look at the answers provided, that is it right there, x plus y, x plus 6. So you're going to type it in with no spaces between your terms. And if you did type it in backwards, x plus 6, x plus y, it should still give you credit. Let's move on to the next question. On this next question, it's asking us to find all the zeros of the function. Zeros, x-intercepts, roots, they're all the same thing. They're all answers. They're all solutions. So they want us to solve this quadratic equation. There's many ways of doing it. You could consider this to be a quadratic equation. Like you could force it to look like a quadratic equation by manipulating it, saying like I want it to be something squared minus something squared, and then find the difference of those two squares. Or the easiest way, I would say, or at least the way to get started without any confusion, would be to go to Desmos and type this in and see if it crosses the x-axis, because that would be a solution, or maybe all of your solutions. Let's check it out. So you don't have to, you don't type it in with m. On Desmos, you would type it in as x to the 4th minus 625, and you will get this graph. It looks like two straight lines, but in reality, we know it's a cubic function, so there is other stuff going on. But even if you zoom out, you'll see that it only crosses at -5 and at +5. So right off the bat, you know that the answers are x equals -5 and x equals +5. Now, the thing is this function or this equation is a 4th degree equation. So it's the power of 4. So I need 4 answers, right? Now, it would have been really cool if the graph would have maybe come down and touched at -5 and then come back down and touched at +5. That way you would have both answers with the duplicity of 2 on each one. So it'd be like two answers, x equals -5 and x equals -5, and also x equals +5 and x equals +5. But that's not the case. They do not actually come down and touch. It actually, as you could see, goes right through like a line. So that's only one single answer with no duplicity. That's another answer with no duplicity. So you only have 2 answers right now, and you need 4. So the other two answers must be imaginary, because if you were to zoom out right here, you'll see that it doesn't cross anywhere else. So the other answers must be imaginary. So what we're going to do is we're going to take this answer and use it to depress it to make it an x to the third. And then once I get my depressed polynomial, I'm going to use this answer to depress it further to get an x squared, and we should be able to solve a quadratic equation. So right here, x is -5. So I'm going to use the first answer, x is -5, put it in the box, and I'm going to do the coefficients of this fourth degree binomial, but I need to represent all powers. So the coefficient of 1 is on the x to the fourth, coefficient of 0 on the x cubed, 0 on the x squared, 0 on the x, and minus 625 on the constant. So with synthetic division or synthetic substitution, the 1 comes down, 1 plus nothing is 1. When you multiply, -5 times 1 is -5. When you come down, you add 0 plus -5 is -5. As you go up, you multiply 5 times -5 is negative, or positive 25, because there was a negative times a negative. And then as you go down, you combine 0 and 25 is 25. As you go up, you multiply, -5 times 25 is -75. As you go down, you combine. That'll be 0 and -75 is -75. As you go up, multiply. -5 times -75 is positive 625. Whoops, probably should have written that in red, 625. And then, of course, the remainder is 0, but that doesn't surprise me because it has to be 0 because I know that this is a solution, right? So this is my depressed polynomial. So it was a x to the fourth. Now it's a x to the third minus 5x squared plus 25x minus 75. But it's kind of pointless to actually write out 1x to the third minus 5x squared plus 25x minus 75. It's better to just use those same list of coefficients, 1, -5, 25, -75. And your other answer, remember your other answer is positive 5. So let's use the other answer, positive 5, right in the box, right next to those list of coefficients. And once again, we're going to do synthetic substitution of that answer, positive 5, and I should have a remainder of 0. So as I go down, I combine 1 plus nothing is 1. As I go up, I multiply 5 times 1 is 5. As I go down, I combine -5 plus 5 is 0. As I go up, I multiply 5 times 0 is 0. As I go down, I combine 25 plus 0 is 25. As I go up, I multiply 5 times 25 is positive 75. And of course, no surprise there, my remainder is 0. It has to be 0. If you don't get 0 at the end, you better go back and double check your work because you need these numbers to be correct. And if you don't get 0, that means that these are wrong. Anyhow, again, what we've done so far is we've converted this fourth degree, depressed it to a third degree, x to the third minus 5x squared plus 25x minus 75. And then we depressed it even further with the other answer to make that x to the third now just a regular x squared. So I have an x squared plus 0x plus 25. So in reality, that's just an x squared plus 25. Okay? Because you don't have to put 0x. Now, if I were to ask you, like the question doesn't say to write it in factored form, but if I did ask you write it in factored form, then you would rewrite it as parenthesis, where did this answer come from? It came from x plus 5. Where did this other answer come from? It came from x minus 5. And we have this leftover quadratic binomial, so we would have that over here, the quadratic binomial x squared plus 25. So this is the factored form, right? If they asked us to factor it, this would be the factored form answer. But they're not asking us to factor it. They're asking us to solve it. And it originally had to equal 0. So I could technically rewrite it in factored form, set it equal to 0, and then split them. This equal to 0, that equal to 0, and this equal to 0. Obviously, we already know that this gives us -5. That was an answer. It crossed that -5. This, when I set it equal to 0, gives me a positive 5. We already knew that because it crosses that positive 5 on the x-axis. This is the only one that we need to algebraically work on that's going to give us imaginary answers. So this x squared plus 25, when I set it equal to 0 and I solve it, I will get imaginary answers. Because I don't have ax squared plus bx plus c, there is no middle term bx. Because there is no bx, you don't have to do the quadratic formula. You could just get x squared by itself. So you could subtract 25, and you will have x squared equals negative 25. And you could get rid of the square by applying a square root, and that'll give you x equals, and when you apply a square root, you get a plus or minus in front of your answer, and the square root of negative 25 is actually 5i. Okay, so what does that mean? We have two answers right here that are imaginary, both the positive 5i and the negative 5i. Those are two answers that are imaginary, and the other two answers are obviously negative 5 and positive 5, and we had that since the beginning when we graphed it because it crosses at negative 5 and positive 5. But those are the two real, these are the two imaginary. That gives you a total of 4 answers, which is according to that degree of 4. So if we go back to the practice test, it says find all the zeros. So we need to, it actually is a multiple choice. And one of those multiple choice answers is the negative 5i, the positive 5i, and both the negative 5 and the positive 5. So just by graphing it, you know that it crossed that negative 5 and positive 5. But of course, without doing all that work that we did, like you're going to get that answer wrong because you could probably see negative 5 and positive 5 and select that one. That's incorrect because you need 2 more answers that are imaginary, and that's where we got the plus or minus 5i. So the correct answer here is the negative 5i, the positive 5i, the negative 5, and the positive 5. On this question, it asks you to write a polynomial function of least degree with integral coefficients that has the given zeros, negative 1, 4, and 3i. Okay, so they give you these zeros, they give you those answers, and they want you to write the equation of a high degree polynomial function that gives you those answers. So we need to, first of all, recognize that x equals negative 1. It came from somewhere. We'll get to that in a bit. X equals 4. It came from somewhere. We'll get to that in a bit. X equals 3i. That came from somewhere. Okay? And there's a theorem that says that if you have an imaginary number as a solution, then the conjugate of that imaginary number is also the solution. So x could also be negative 3i. Okay? So if you got x equals 3i, then x could also equal negative 3i. And in reality, you could think about it and not have to deal with this whole process, and I'll explain in a little while. But where did this answer come from? It came from the binomial what equals 0?
X plus 1.
X plus 1 equals 0, right? So if you add 1, you get the x plus 1, and you have the equal 0. That's where the answer x minus 1 came from, or x equals negative 1 came from. How about the next one? Where did that answer x equals 4 come from?
X minus 4.
X minus 4 equals 0, right? If you solve x minus 4 equals 0, it'll give you the answer x equals 4. Same rationale, same movements. How do we get this one?
X minus 3i.
X minus 3i, right? Like if you didn't know, you could be like, I want to get rid of this 3i by subtracting 3i. It'll cancel out, which do to one side, do to the other. And that's how we get the x minus 3i, and it will be equal to 0 because that cancels out. So equal to the 0. And likewise, what's that last one?
X plus 3i.
X plus 3i equals 0. Okay, so everybody understands that, right? So now we're going to take these binomials and we're going to put them together using zero product property backwards. And we're going to end up with, this is a long process, x plus 1 times x minus 4, and then times the x minus 3i times x plus 3i, right? And it's equal to 0, right? If we were to put them all together. But at the end of it all, we don't even care about the equal 0. We just want the actual polynomial function. So we have to do a lot of distributed property and combining like terms, So let's go and do the imaginary one first. I think that one's a better one to start with. X times x is x squared. X times 3i is 3ix, or 3xi, whatever. And then negative 3i times x is a negative 3ix. And negative 3i times positive 3i is negative 9i squared. And we should all remember that I squared is really equal to negative 1, okay? So the I squared is going to change to negative 1. The middle term, negative 3x, or positive 3x 3ix and negative 3ix, those eliminate because they're exact opposites. So what we really have is x squared minus 9 times negative 1, right? Because I squared is negative 1. So negative 9 times negative 1 is positive 9. So I end up with x squared plus 9. Because a negative 9 times a negative 1 is positive 9. So in reality, these two binomials, these two complex binomials, when I multiply them and distribute, I end up with just the beautiful x squared plus 9. So that is a binomial. And I'm going to go back to these two, and I'm going to distribute, okay? So right here, x times x is x squared, x times negative 4 is negative 4x, positive 1 times x is positive 1x, positive 1 times negative 4 is negative 4. The middle terms, negative 4x and positive 1x, you could combine that to get negative 3x with the minus 4 with the x squared in the front. So these two binomials multiplied together gave me this trinomial, okay? So we still need to multiply the original trinomial with this binomial, okay? So let me do that somewhere. I want to do that. Where could I do that? I'll just rewrite it up here. The x squared plus 9 times the x squared minus 3x minus 4. So we're going to distribute x squared times x squared. That is x to the fourth. X squared times negative 3x. That is a negative 3x to the third. X squared times negative 4. That's negative 4x squared. And then we need to distribute the 9. Now this is where it gets a little tricky because I'm going to start combining already. Check it out. The positive 9 times x squared is a positive 9x squared. And where am I going to write that? I'm going to write that underneath the other x squared so I could combine them. So positive 9 times x squared is a positive 9x squared. Write it below the other x squared term so we could combine them easily. And then positive 9 times 3x, that'll be or negative 3x, that'll be a negative 27x. And last but not least, 9 times negative 4 is negative 36. So I just put them stacked. That way you could clearly see that I'm combining these two. And when I combine those two, I will get a positive 5x squared. Okay. What about the first two terms of this quartic polynomial? You got the x to the fourth, bring down the minus 3x to the third. Then you got the minus 27x and minus 36 at the very end. So there's your answer to this problem. I believe, what do the instructions say? Yeah, write a polynomial. Okay, so it's a multiple choice question. So that's big and ugly, but if you look at the multiple choice answer, it's the same exact one right there. Okay, so that's the one that you pick on the multiple choice. So on this question, it's a piecewise function, and they want us to write the piecewise function. It's kind of weird the way it's printed out, but you could see it's an open dot here, and it should have an arrow going this way, and we have a solid dot down here and an open dot up here. So we're going to look at this piecewise function from left to right, and from left to right, we look at this piece of a line that originally was the whole line. And that whole line was a horizontal line crossing the y-axis at the value of 2. So to begin, we would say f of x equals big giant nasty bracket. And the first equation up here is this line right here. And that equation is y equals 2, right? But the y equals 2 would give you the whole line. But this is what I'm going to do. F of x is really y. So y equals, I'm going to put a 2 up here. Now the condition, if what? If x is to the left of the x value of negative 1, right? So obviously the line doesn't exist that way to the right. It exists from this way to the left, and it's an open dot. So if x is less than that x value of negative 1. So if x is less than negative 1, okay? Now when we look at this next line, This next line, you need an m and a b to actually write the y equals mx plus b equation. So it's really easy to see the b value. The b value is at -3, and it does rise 1, 2, and it runs 1. So the m, let me write the whole equation, y equals, it does rise 2, run 1, so the slope is 2, so y equals 2x, and it does cross the y-axis at -3. So y equals 2x minus 3 is the equation of this entire line. But right here we only have the piece from this x value to this x value. That x value is -1 and this x value is 2. So let's first begin by writing the equation y equals 2x minus 3. This is y, this is equal. I am just going to write down the 2x minus 3. And then we need the condition, because it's not the entire line, it's only from this solid dot to this open dot at the x value of -1 to 2. So it's from -1 to 2. So I'm going to put if, I'm going to put the -1, I'm going to put the 2, I'm going to put x in the middle, and they have to be less than symbols on both, right? And this is a solid dot at -1 on the x, so that means that this is a solid line underneath the inequality. And this one's an open dot, so I don't put a solid line, it stays like that. Now for my third and final piece, my third and final line right here, the slope, as you could see, is up 1 over 1. So I so far have y equals up 1 over 1 is just 1x, and then the b value, where would it cross if I go up 1 over 1? Where would it cross the y-axis? If you go backwards, over 1, down 1, over 1, down 1, over 1, down 1, it would cross at 1. So y equals 1x plus 1. Okay, so that's my line, but y equals 1x plus 1 is the entire line that crosses through 1, and obviously we don't have this piece of the line showing. It starts existing here with a solid dot to the right of the x value of 2. So we're going to say x is greater than 2. So again, the equation is y equals 1x plus 1, y equals, I'm going to put a 1x plus 1, I'm just going to write x plus 1. I'm not even going to put the 1 in front of the x. But the condition is if my x values are greater than or equal to the x value of 2, because that's where it begins, at the x value of 2. Greater than or equal to the x value of 2. Ladies and gentlemen, that is the answer. If we look at the way they type it out on the test, you'll see it right there. It's the same exact thing. So we're good to go, I hope. And last but not least, describe, or given the graph, describe the end behavior, state the degree, and determine whether odd or even, state the number of real zeros. Okay, so let's start with the first thing they asked for, describe the end behavior. Obviously, it's going to the left and up, and to the right and up. So this has to be an even degree function. So let's take a look at the end behavior first. And A is end behavior, so we're going to say as x approaches -infinity, your f of x, your y values are approaching, so think about that. As you go to the left, where are you going? You're going up forever, so you're going to positive infinity. And as x approaches positive infinity, that means as you look to the right, positive infinity on the x is to the right. As you go to the right, you're going up also. So your f of x values also go to positive infinity. Okay, that's A. This is the answer for A so far. That's the end behavior. Part B, it says state the degree. Okay, what is the degree? Well, it's the number of directions that it goes in, right? So it's going in one direction, and then that degree would be at least 4, okay? But they don't even tell us, they just say, state the degree, yeah, okay, and determine whether it's odd or even. Well, obviously it's 4, it's gonna be even. Why? Because it goes 1, something happens there, 2, 3, 4, okay? And we know it has to be even because both end behaviors are up on top. So we have the degree 4, and it's even, of course. State the number of real zeros. How many real zeros do we have? We have 1 real zero right there, because a real zero is a real solution, a real answer, a real x-intercept. There's another one right there. So there are two real zeros. Two real zeros. I mean, if we actually had the numbered line, we'd be able to tell you what specifically those real zeros are, but we don't. So that's it right there.